All right, I'm now recording. We are going to stop about 10 minutes early today, so those of you who are here and haven't seen your exam, I'll let you have some time to look at that. Any questions before we get into the material? All right. We are starting in on chapter 28, which is a very important chapter. Not a chapter we're going to spend a lot of time on, and we won't cover everything in the chapter. We won't cover all the details. Excuse me. In the chapter, but there are some very, very useful ideas because one of the most important things we're interested in is over time, are things going to get better? Are they going to stay the same? Are they going to get worse? And what we cover in this chapter will give us some really important insight into the answer to that question. It's a complicated issue, but it will point our attention to some things that are very important and give us, at first it will look like, this looks kind of disturbing, but by the time we get to the end of the chapter, end of class, there's actually reason for optimism as far as the long run is concerned. If you have one other note before we get into it, if you have any comments about the textbook, something you like, something you don't like, suggestion for improvement, email that to me sometime today, because I'm gonna later today and tomorrow I'm going to be participating in a virtual academic conference where the authors of the textbook are going to be doing some presenting, and they have question and answers. So if you have something you would like to convey to them, you like it or you don't like it, they would be very interested in that. Callan and Tabarrok, the authors, very interesting people. I went to a live session similar to this last year, and when I walked in, it's a big conference area. When I walked in, the first thing I saw was Alex Tabarrok at a table, and nobody was sitting with it. So I got to sit next to him, and we had an interesting talk. And you benefited from that talk, because one of the questions I asked him was, I forget which chapter it was, but I said, that's a great chapter in your book. Do you actually have time to get to it? And he said, no, I feel guilty about it. I feel like I ought to cover it, but I don't have time for it. So I feel better about not covering everything, because he doesn't cover everything that he puts in his book. So any thoughts on the book, send it to me. All right. Today in chapter 28, growth, capital accumulation, and the economics of ideas. We're interested in what leads to growth. We've already talked about these questions before from one perspective, but in this chapter, we're going to be talking about it in terms of a particular model. It's called the Solow growth model, S-O-L-O-W, after economist Robert Solow, who came up with this idea initially. And much of this we've already mentioned, but this is a good graph to summarize important things. What determines living standards, what determines GDP per capita, lots of things have an impact. Geography, actually this is a graph from, or a chart from chapter 27, so you've already seen it, but it's good to review. geography, history, ideas, attitudes, culture. Lots of things have an impact. And those things have an impact on institutions, our legal system, our police force, our attitudes toward the law, the court system, how our rules are made. All of those things have an economic impact. They have a moral dimension, but they also have an effect on how much we're going to be able to produce, because our institutions have an effect on incentives. If you live in a country under a system where you believe that if I work hard and I save and I invest and I'm productive, I'm going to benefit, then you have a lot of incentive to work hard and save and to invest. If you live in a system where you think the rules are set to help other people, but they don't work for me, then you think, well, I'm not going to benefit from working hard and being productive and saving, and so you don't have as much incentive to do that. So the institutions affect the incentives people have to be productive, and that's really important. But also the factors of production available. Okay? Physical capital. Do we have machines, tools, factories that enable us to produce the things we want? Human capital, the knowledge and the skills that people have acquired through education, through experience. Those things are really important. Doesn't do you any good to have lots of physical capital if you don't have the people who know how to use it. Likewise, if you have the people, but you don't have any physical capital, your ability to produce is going to be rather limited. Right? And in addition to having these things, you have to know how to organize those resources. Just think about the complexity of the U.S. economy. We've got millions of people, millions of products that can be produced, enormous range of resources. How do we figure out which products to produce? And then for each product, how do we figure out the best way to produce that product? It is incredibly difficult. So you have to have people who know how to look at all of this and figure out how to organize a business. Studying business administration, that's a big part of what you're trying to learn. How does an organization function to produce the things that people want? Then, of course, technical knowledge. Our technical knowledge determines how much we can produce from the resources that we have. Doesn't do us any good to have billions of barrels of oil if we don't know how to take that oil and produce energy from it. So the technical knowledge is very important. Notice you got a lot of things here that have an impact on how much we're going to be able to produce and on what our living standards are going to be. And if you maybe do great on some of these, a country may do great on some, but then terrible on something else. If you really want to be successful, then you have to get all of these things right. They are all prerequisites for having a growing economy. In this chapter, we can't talk about everything, but we're going to be focusing on a few very specific things, and primarily 4 things. The idea of a production function. We're going to see that it's not very complicated, but it's a very powerful idea to use to organize your thinking. Capital accumulation. I already talked about capital. That's the machines, tools, factories that we have. Capital accumulation just means over time you're accumulating more capital. You're getting more of those productive resources. We're going to talk about how that works. And then we're going to talk about 2 different types of growth: catching up growth and cutting edge growth. Okay? And as we go through this, remember what I've said before. There are a lot of details, some of them very technical in this chapter, but I don't expect you to have a complete grasp of all those details, especially in chapter 28. The questions that I ask you on the exam will come from the questions that you find in the MRU videos. Okay? So you do not have to remember everything we're covering here, but what we cover will help you. You won't remember all the details, but if you try hard to follow those details, when we get to our end result, our conclusions, those conclusions will make more sense to you. And that's really the goal here, is for the conclusions to make sense to you. Book points out that in 2010, US GDP per capita grew by 2.2%. In China, GDP per capita grew at nearly 10%. Big difference there. And some people really worry about that. Why are we growing at such a much lower rate than China? What's the explanation for that? Well, no doubt there are a number of things that contribute to it. We're going to see in this chapter that there's one cause of it that is pretty undeniable, and it's something that we don't need to worry about. Bottom line is this: the U.S. economy is experiencing a particular kind of growth, cutting edge growth. The Chinese economy is experiencing catching up growth. And we haven't defined what those mean, but in a few minutes, I think you'll see that the difference isn't all that complicated, even though the graph we're going to look at does look complicated. Okay, here's the basic ideas of the SOHO growth model. Okay? Begins with a production function. Now, in math, what's a function? What's that idea? It's a formula or an equation that shows you a relationship between variables. For example, if I have whatever is on the x-axis, whatever is on the y-axis, then I can say that y is a function of x. Simply means the variable on the y-axis depends on what the value of the x variable is. And so if I had something that, just hypothetical, if I had a line that looked like that, okay, well then the function would be an equation that would allow me to plug in any number for x, and say 1, and if I plug that in for x, then I would be able to determine what the value for y would be. And if it was something simple, if it was like y equals 2x, then that means if x is 1, what's y going to be? It's going to be 2. Okay? Just a simple function. What the idea that we're looking at here is, with the SOHO model, is that in one sense, it's just obvious. The amount of output that we get depends on the inputs that we have. That's really the point of the previous chart. All of those different things have an impact on how much output we're going to get. And so we talked about, we're going to use Y to represent the total output or GDP of the economy. To represent the amount of physical capital we have, we're going to use K. To represent our human capital, okay, which depends on how much labor we have and on how much education people have, we're going to use that, represent that by EL. So when you see EL, just remember that's human capital. Okay? And then We're also going to emphasize the importance of ideas or technological knowledge. The better our technology is, the more output we're going to get. So we're going to, with this solo model, we're going to focus on the importance of these three factors. And we're going to, the other things that have an impact on output, like culture and institution, we're going to hold all those constant. So for what we're doing, we're assuming that they're not changing. The production frontier shows us if we vary the amount we have of these other things, these factors, shows us how output is going to change. Okay. To keep this as simple as we can, we're going to start out by assuming that A, ideas, E and L, our human capital, are constant. So they're just fixed numbers. And that means we can simplify our production function to be Y equals F of K. All that is saying is the amount of output we get depends on how much capital we have. If we have more capital, that means we have more machines, more tools, more factories. We'll be able to produce more output. That's the whole idea there. Now, so that we can draw a graph, that's going to be helpful, we are going to assume a specific production function. And the function we're going to use is Y equals the square root of K. Now, don't worry, well, why are we using that one? It's one we can use. It's a hypothetical production function. And the reason that is a pretty good one to use is because it has two important characteristics. If this is the production function, when we get more capital, what's going to happen to output? It's going to go up. We get more capital, we're going to get more output. You see that here. If we have 4 units of capital, then output will be the square root of 4, which would be 2. If our capital goes up to 16, which is a big increase in capital, then we're going to get our output is going to be the square root of 16, which would be 4. So we got more capital. There we are. We got more capital, and as a result, our output went up. That's pretty obvious that a reasonable production function will give you that result. If you had a production function that said the more capital you have, the less output you'll get, you know, that something's wrong with that. The other characteristic of this production function that makes it useful is that it does give you an economy where they will experience diminishing returns. Right? We're not going to go into that idea of diminishing returns in much detail, but the idea is pretty straightforward, that as you add extra units of output, or I'm sorry, as you add extra units of capital, your output will go up, but it doesn't, the amount of extra output you get diminishes. In other words, you add the first unit of capital, your output goes up a lot. You add another unit of capital, your output goes up again, but the increase isn't as large. As you continue to add more capital, each time you do, output continues to go up, but the additions are getting smaller and smaller. Kind of like diminishing returns to studying. If you have an exam and you study for an hour, well, there's going to be a big benefit from that because you didn't know anything before you started studying. When you maybe reading the chapter, let's say that you read the chapter, there's a huge benefit to doing that. Right? If you go and read it a second time, well, there's going to be a benefit to that too. You're going to know more at the end of the second reading than if you only read it once. And if you read it a third time, you're going to learn even more. Your knowledge is going to continue to get higher and higher as you read the chapter more and more. But if you read it the fourth time, even though that fourth read adds something to your knowledge, it's not going to add as much as reading it the first time did. That's diminishing returns. As you add more capital, your output goes up, but the increases in output get smaller and smaller. And we can see that in this graph. Anytime you look at a graph, stop, take your time, and look carefully at what is on each axis. On the horizontal axis, we have the amount of capital that this economy has. On the vertical axis, we have the amount of output they're going to be able to produce. And the blue line is representing the production function. It's showing you how much output we're going to get as a function of how much capital we have. Now, ideas and human capital, we're ignoring that for now. We're saying that we're assuming those things are constant. And the only thing we're changing is the amount of capital that we have. And think about, what does that upward slope tell you? It tells you as the economy gets more and more capital, what's happening to output? It's getting higher and higher. Okay? The curve is always upward sloping. But the fact that it's getting flatter represents diminishing returns. When you add that first unit of capital, output goes from 0 all the way up to 1. Okay? So one extra unit of capital added a whole unit to output. But if you get out here at, say, 9 units of capital, okay, then we're able to produce 3 units of output. If we increase and we add 1 more unit to capital, what happens to output? You can see it does go up, goes up to 3.2, but the increase is a lot smaller. That first unit of capital added 1 full unit to output. The 10th unit of capital adds only 0.2 units to output. So the upward sloping but flattening production function is telling us that the more capital we have, the more output we get. But as we get more capital, we encounter diminishing returns. The extra capital isn't helping us as much as it did when we didn't have very much. Okay? Question so far? It's a graph that conveys the intuitive idea that you get more capital, you can produce more output. Okay, now what can we learn from this? How does the capital stock increase? Here, we're showing that if we get more capital, output's going to go up. But that doesn't tell us how do we get more capital. It doesn't just fall out of the sky. How do we get more capital? Well, capital comes through investment. Capital is output that is saved and invested rather than consumed. When we produce something, we can consume it. We can just use it for our current consumption and benefit and pleasure, or we can save it so that it will add to our capital stock and we'll be able to produce more in the future. Roughly, you can think of it as, think about your income. You earn a certain amount of money this year. You can spend all of it on consumption this year and you enjoy that. But then next year, you don't have any more than you had this year. But if you say, well, I earned $20,000, I'm going to save $5,000 of it. I'm only going to consume $15,000. If you save $5,000, that means next year you're starting out in a better position. Okay? And the same thing is true for the economy as a whole. Capital is output that has been saved and invested rather than consumed. For example, if you have 10 units of output that are produced and you decide to use 7 of those for consumption to benefit you in the present, then that means you've got 3 that are left over. Those are invested, and that means you start the next period with more capital than you had this period. Okay? So the way that we get new capital is through investment, which means we get new capital by not consuming everything we produce. And we're going to make a simplifying assumption that for this economy, 30% of output is invested, in other words, used to produce new capital. So that means if we produce 10 units of output in a particular year, 7 units will be consumed, 3 will be invested. And so that means that next period, our capital stock is going to be 3 units larger than it was this period, right? Except for one problem. This, our equation here is important. That's just the assumption we're going to make. It tells us how much investment we're going to have. But there's a problem. Unfortunately, capital depreciates. You're running a business, you've got, let's say it's a delivery business. You've got several vehicles you're using to deliver products. Okay? You buy a new truck, it's nice, shiny, smells good. You think this is going to last forever. But is it going to last forever? No, just like everything else, it's going to wear out. Okay? And that means it's going to have to be replaced at some point. So investment is the way that new capital is added, but simultaneously every year, capital that we already have is depreciating. It's wearing out. For example, if we have 100 units of capital when we start the year, some amount of that capital is going to depreciate. It's going to wear out. Let's assume that for every 100 units, 2 units are going to depreciate, which means you end up with only 98 for the next year. This equation is what we're going to use to represent depreciation. We're just going to assume that every year, 2% of our capital is going to wear out. So every year we got 2 things happening. We are having investment, which adds new capital, but at the same time we have depreciation, which is causing our old capital to wear out. We have control over how much investment we do. We really can't prevent depreciation. That's not up to us. That just happens. Okay, so let's think about what these ideas mean in terms of our graph. Okay? Same production frontier as before, but we've added something. We put in a green line that represents investment, and this is just our assumption that we're making, that investment spending each year will be 30% of our output. Okay? So let's assume we're starting out here with 100 units of capital. With that, that means we're going to be able to, actually it's right here, that means we're going to be able to produce 10 units of output. And our equation here tells us that we're going to choose to invest 30% of that, which would be 3. Okay? This is the amount of investment we're going to have. And the amount we're going to devote to consumption, that amount is going to be the 70% that's left over after we do the investing. So if we're starting out at 100, we're producing 10 units of output. We're going to consume 7. Okay? How much we consume, that determines our standard of living. The more you can consume, the better off you are. And we're adding, we're producing 3 units of extra capital, which means that in the coming year, whereas this year we start out with 100, next year we're going to start out with 103. Okay? So we are moving in the to the right because we're getting more capital because we're investing. Okay? That's what would happen if we didn't have any depreciation. But now we have to take the depreciation into account. Here we've left off the production curve. It's still there, but they left it off just so it wouldn't look too complicated. We've got the investment curve we talked about in the previous graph. Here, all we're adding is a depreciation line. And our equation, our assumption is that depreciation will be 2% of capital. So that just gives us a straight line. For every, if we have 100 units of capital, depreciation will be 2. If we have 200 units of capital, depreciation would be 4. Okay? So our two assumptions about investment and depreciation, those give us these two lines. Okay? Questions so far? All right. If we are at 100, okay, that means this year, we've got at the beginning of the year, we have 100 units of capital. That's going to enable us to produce 10 units of output, which is going to be way up here somewhere. Okay. This point is telling us that we're going to produce 3 new units of capital. That's going to be added to our capital stock. What's this point telling us? 2 units of capital is going to wear out. So we're adding 3, we're losing 2. What does that gap represent? Well, that's the difference between the new capital we're producing and the old capital that we're losing. You can kind of think of it, think of the capital stock as like a bathtub. Okay? You've got a bathtub where the water in the tub is the amount of capital that you have at a point in time. You've got a faucet that's pouring water into the tub. Okay? And every time water comes in through the faucet, the level is going up. That would be the investment. Okay? But you've got a drain where water's flowing out. That would be analogous to depreciation. So we've got investment, which is raising the level. We've got depreciation, which is lowering the level. What happens to the capital stock depends on which is greater, investment or depreciation. And we see that if we're at 100, we're adding more than we're losing. Okay? The new capital flowing into the tub is greater than the amount going out the drain, and so the level is going to go up, which means that in the next period, we start that period with more capital than we had this period. Okay? That's the key idea here. Investment greater than depreciation if we're starting at 100, and so the capital stock is going to grow from period to period, and that means our output is going to grow. Our living standards are going to grow. Okay? Questions on that? All right. Here, same graph, but we're making a different assumption about where we're starting. Here we said, what if we're at 100? What's going to happen? Our conclusion was the capital stock is going to grow over time. Here we're saying, well, what if we're actually at 300? What's going to happen over time? And we see that reading up to the investment curve, that shows us how much new capital is going to be produced during the year. What does this point tell us? That's the amount of capital that's going to wear out during the year. So if we're at 300, that's not sustainable, because our the new capital we're producing is not enough to replace the old capital that's wearing out. So investment is less than depreciation. That means that at the end of the year, we've got less capital than we started with. So the capital stock is going to decline. Okay? So think about the implications of this. If we start out at a low level of capital, then it's going to grow. If we start out at a level that's too high, then the capital stock is going to shrink. So think about the logical implication of that. We're not going to remain up here. We're not going to remain down here. Over time, we're going to be moving toward 225. And that is called the steady state stock of capital. Because once we get to that, we've reached a point where investment and depreciation are equal. Okay? Looks like that would be at 5. Okay? So if once we, in the long run, we're going to end up at 225, which means that each year the amount of new capital we produce is 5, and the amount of old capital that we lose through depreciation is 5. So we're replacing what wears out, but we're not doing anything more than that. So over time, if this is all that's happening, over time, we're going to remain at 225, and that means whatever the output level is that corresponds to that, that's where we would remain. The steady state level of capital and level of output is the level that we get pushed to in the long run if there's not anything going on in the economy other than capital accumulation. Okay? And here we see the end result, that if all that's happening is capital accumulation, we are going to end up at a point like that, and that's where we're going to stay. Next year, the capital stock will still be 225. Next year, investment will still be the same. Next year, output will be the same as it was this year. And if output is the same year after year after year, what's the growth rate? If you look at your savings account and you see, well, last year I had $300 and now I have $300, and the year before I had 300. The growth rate is 0. It's not growing. So this is a conclusion that we look at and say, well, that's not real encouraging. For the long run, it looks like we're not going to be able to have economic growth indefinitely. And there's some truth to that if we look at it the right way, but it's not the whole story. We're getting to the whole story. Okay, now we remember we started out talking about China versus the U.S. We said that China has had very rapid growth in recent years, much greater than the United States, and that worries a lot of people. But what we can, if we think about what we've already done, we will see that that is not at all surprising. If you look at where China was a few decades ago, they were very, very poor. Their capital stock was very, very low. So, say 50 years ago, where would China be on this graph? They're going to be way down here. They're going to be at the steady state. They're going to be over here somewhere. They're going to be at what they had a very low capital stock. And if you have a very low capital stock and you add just a little bit, what happens to output? It goes up a lot. Poor countries are in this area down here. They don't have much capital. And so when they add some capital, the marginal product of that capital is very high. They get a high growth rate because they're starting from such a low level of capital. Adding some capital, it's very, very productive. Think about, kind of putting it on an individual level. If you didn't have a car and you had to walk everywhere you went, how productive would it be for you to be able to have a car? It'd be incredibly beneficial. If you had to walk everywhere, you couldn't be very productive. So getting that first car would be enormously valuable to you. Getting a second vehicle, well, that would be useful too, but it wouldn't be nearly as useful as getting that first car. Well, in countries like China, you got a lot of people equivalent to not having a car. Okay? Farmers not having a tractor, okay? Having to do everything by hand. Well, when they get those first tools, it increases their productivity enormously. And that's why they get a big increase in output, and that means a very high rate of economic growth. A country like the United States that is much more wealthy, we have a lot more capital, okay? Which is a good thing. Okay? But that means that we are much further along that production frontier. And you can see the production frontier is a lot flatter here than it is over here. So you've got the poor countries who are back here. They are going to experience a very high rate of economic growth. Okay? You've got more wealthy countries that are over here. Their living standards are much higher than the poor countries, but their rate of growth is much smaller. Right? So would we like to have a higher growth rate? Sure, we would, but we're glad that we're here. We're glad that we have a lot of capital. The declining growth rate is just something we should not be surprised about. We shouldn't be especially worried about it. What's going to happen in the poor countries if they continue to advance? Their capital stock is going to go up. That's good. Their output goes up. That's good. Their living standards go up. That's great for them. But as that is happening, they are moving up along the frontier, or the production function. And what's happening to the slope of the curve? It's getting flatter. Right? So the poor countries or undeveloped countries that have high rates of growth, that's great. It's helping them to get out of poverty, but they shouldn't and we shouldn't be surprised that over time, they are moving along that frontier, their growth rates are going to go down. Okay? We shouldn't be surprised that we see lower growth rates than they do because we are further along this curve. So this disparity of growth rates, high growth rates for poor countries, low for rich countries, is not at all surprising. You can see it with this graph that we have. Chinese growth has been rapid because China began with very little capital, so marginal product of capital was high. Their growth rate will fall, and it doesn't mean they're doing something wrong. It's a implication of the curve. Their growth rate is going to fall because the marginal product of capital will fall as it approaches the steady state level of capital. Notice the poor country, they are moving in the direction of the steady state level of capital, and so is the rich country. The model as we're looking at it right now, everybody is moving toward that steady state capital stock. And that would suggest that given enough time, where are we all going to end up? Suggest we'd end up at the same steady state capital stock, same level of output, same standard of living, and the growth rate in the long run would drop to zero. Okay? That's not something that's real encouraging. Okay? And that's kind of a pessimistic conclusion from the simple Solow model. What we want to consider is, well, are there things that we can do so that we can have growth indefinitely in the long run? Okay? And there are a couple of things to think about. What can continued capital accumulation give us growth forever? Okay? Can we just keep adding more and more capital and that causes our output to go up? Well, the answer, initially, if you look at it, once we get to the steady state level, then we're stuck there as long as investment remains at 30% of output. If we want growth to continue in the long run, what could we change? What could we do differently? This is where we could increase investment. As long as investment remains at 30% of output, then we're going to end up here. Okay? So we could say, well, we're going to invest more. We're going to invest 40% of our output. So each year we'll use 60% for consumption. We'll invest 40%. Is that going to work? Well, that will help. Okay? Here you see the same graph as before, but now you see two green curves. The original investment curve, where we're investing 30%, but now we got this new one where we're investing 40%. And with that curve, recognize as long as we were at 30% investment, then our steady state level of growth was right here. We're going to be stuck there. But if we're now investing more, now the investment curve has shifted up. At 225, our investment is now going to exceed depreciation. And so our capital stock is going to continue to increase. So investing more will help. But notice, what does that point represent? That's a new steady state level for the capital stock. because we're investing more, we are going to get more capital. We are going to get higher output, higher standard of living, right? But eventually we get to here, and that's where we're going to be. Well, can we increase investment again? Well, yeah, we could increase it to 50%, could go maybe to 60%, but there's a limit to how much investment can be. Obviously, mathematically, the most you can invest is 100%. And if we were investing 100%, then there wouldn't be anything left over for consumption. So, we don't know exactly how high we could raise that investment rate, but it's clear there's a limit. So at some point, we cannot raise the investment curve. So at some point, we hit a level of output where we can't go above that. Which again, here it looks like, well, even if we're willing to invest more, somewhere out there in the long run, it looks like we cannot have any more economic growth. Things start to stagnate. Okay? So again, we have a kind of a pessimistic conclusion, but we're not done. Excuse me. Well, one term I didn't mention, the idea of conditional convergence. It's the idea that when you have countries with similar steady state levels of output, poorer countries will grow faster than the richer countries, so they tend to converge to some common level of income and output. So that's just the name that we give to that idea. Go back to our question. Can growth continue in the long run? We can increase the rate at which we invest, but there's a limit to that. So is there some way that growth can continue even in the long run? And here's the answer. In the simplest model, the conclusion is, in the long run, we're going to get to zero economic growth. We reach a high level of output, and we just can't go any higher than that. But in the United States, for over 200 years, output keeps growing. Okay? Why is that? Well, go back here. The growth, the way to think about this is we can distinguish between two different types of growth. When you have countries that are below their, let's go back to this one. When you have a country that is below their steady state capital stock, then that country is experiencing growth that we're going to call catching up growth. China, for example, we would say is experiencing catching up growth. Why are they growing so fast? Because their capital stock is way below the steady state. It's way below our capital stock. And so they are catching up. They are having growth that we've already had, because we've already added that capital. So for a country that is anywhere in here below the steady state capital stock, that is, we're calling that catching up growth. And the United States has experienced catching up growth, and much of a significant part of our growth has been catching up growth, but it's not the only thing. And here is the key idea. Better ideas can keep the economy growing even in the long run. Think about a computer that today has the same amount of silicon and labor input. In other words, the inputs we use to produce it, they're pretty much the same as 20 years ago. But today's computer, today's chips are much better. And the difference is ideas. Okay? What difference does that make? Let's go back to our production function. We had simplified it and we were just saying y equals the square root of capital stock. But now let's go back and put A in. Remember, A stands for the ideas, the technological knowledge that we have. When we get better ideas, better technology, then we can represent that as an increase in the value of A. And if A is increasing, that means that the amount of output we get goes up, even holding the capital stock constant. Okay? And we see that here. We said as long as we are depending on capital accumulation for growth, that's going to come to an end. Okay? Eventually, we're going to hit the steady state level of output, and as a result, we can't grow anymore. But what we're saying here is if we get new ideas, better technology, then that increases the value of A, that changes the production function, and that means, notice what we have here. The effect of better ideas is that for the same amount of capital stock, we get more output than before. The frontier is shifting up. And whereas there is a limit to how much growth we can have from capital accumulation, there is no limit to the growth we can have from new ideas. There isn't some finite amount of ideas that once we think of them as well, there's nothing left we can think about. There's no limit to the amount of new ideas and new technologies that can be developed. And I think this is one of the most important and exciting ideas in this chapter and in the whole book, really. The future of economic growth. The number of new ideas is a function of the number of people, the incentives to innovate, and the number of ideas per hour that each person has. And you can represent that, I mean, this is just a hypothetical, but it's useful to help us think about it as ideas equals population times incentives times ideas per hour. Okay? Many people, when they think of population, they think of population as a negative, that how are we going to feed all these people? And we need this to stop the population from growing. Then we'd be better off. The authors of your book take a very different view. And they would say, well, when the population grows, that means you have more people thinking. Okay? And as growth occurs and living standards go up, you have more people who can actually do a lot of thinking. Imagine somebody who is the intellectual equivalent of Albert Einstein, but he is born in Ethiopia, and a country where they're having great difficulty just keeping people alive. So he's the equivalent of Albert Einstein, but he never goes to school. He never learns to read. He works in a field growing some food. Nobody even knows the enormous human capital that he had. He could have become very productive. He could have come up with lots of good ideas, but we never know about it. How many Albert Einsteins grow up in those really, really poor countries, and they never produce anything. They never produce any ideas because the country is so poor. But as growth occurs and living standards go up, then you have literally billions of people who now have access to better health, better education. And we start finding, oh, there were some really smart people in those countries. And now they're starting to get more education. And when they get education, then they start producing ideas that we weren't getting before. So as the population grows, if we have, and as living standards go up, as have gone up in recent decades, if we have economic systems that give people an incentive to work and to come up with new ideas, okay, then the number of new ideas we get doesn't have to reach a steady state. It can continue to grow at a rapid rate. It may grow at a faster rate than in the past. So potentially we could experience faster rates of growth in the future than we have in the past. We're not going to get that growth simply from capital accumulation. But when you take into account the importance of ideas, then there's a lot of reason for optimism. The number of people is increasing as the world gets richer. The number of people whose job it is to produce new ideas is increasing. Your book talks about spillover effects. I'm not really going to go into that, but the basic idea is when somebody comes up with a new idea, everybody can benefit from that. Okay? So if we've got more people around the world thinking, coming up with new ideas, we can all benefit from all of those new ideas. And so the frontier can continue to shift up, not because of capital accumulation, but because of what the book calls cutting edge growth. Okay? The growth that occurs from capital accumulation as we're moving along the frontier, that is catching up growth. The growth that occurs when we have new ideas and that shifts the curve up, that's called cutting edge growth. And that gives us reason to believe that the future really can be better than it is in the present. What we've said here doesn't go into detail about the importance of institutions. Those things are really important, but this is simply focusing mainly on two things: capital accumulation and the importance of ideas. Okay, just the last two slides are some summaries you can take a look at in the video. Okay, I'm going to stop now and let the people here take a look at their exams. If you have any questions, let me know. Okay. And your camera.
Cyrus.
I'm sorry?
Cyrus, that's what you want.
Caleb? Charmaine? I didn't get into all of that. So if you want to write and take notes, that's fine. If you have any questions, just